I think we're already around 15 attendees in, so and it's 10 o'clock. So yeah, good morning, ladies and gentlemen, and welcome to our panel discussion webinar, where we will dive into the day in the life of a reliability engineer. We appreciate your time and really trust that you will enjoy this session. It's going to be very interactive and just talking, and yeah, it's not going to be a lecture or training or anything like that. So really sit and enjoy it. You will see there is a chat box during the session. If you have any questions for the panel, you can type the questions and then they will answer by typing back. So for the agenda for today, so we're just going to start with just introducing myself and the topic for today. Then introducing our panel of active reliability engineers in the field. They're just going to say who they are and where they're from and what they're busy with and their backgrounds. And then after that, we're just going to jump into 5 questions. And the panel is going to answer the questions. Some of them, we nominated a couple just to elaborate a little bit more on them. And yes, it's going to be really an open and relaxed discussion on this topic. So this will take around 45 minutes, and then thereafter, we will take 15 minutes for questions to the panel, and then close the webinar afterwards. So yeah, the opening session, to open this session, my name is Johan Alberts. I'm the Sector Executive at Pragma. And really looking forward just to host this with the experts we've got on the panel. And just around an introduction is, the role of a reliability engineer forms a critical cornerstone in really meeting an organization's asset management objectives. So based on the article, I don't know if you've read it, it was on all the social media, the LinkedIn's and links to our website. But based on the article released, the webinar will focus specifically on that, in what is the true role and responsibilities of a reliability engineer. This will include where and how they fit into an organization, the data they require, and then their key challenges, day to day, and what possible solutions are to address these challenges. And then in more recent times, also includes digital transformation and how the industrial Internet of Things will influence the future activities of the reliability engineer. So yeah. Next on the agenda is really, I would like to thank the panelists for supporting me in this and making yourself available from the sites where you are. And let's start to introduce yourself. I will nominate, so let's start with Nardes Groenewald.
Thanks, Johan. Morning, everyone. My name is Nardes Groenewald. Like Johan said, I'm a reliability engineer. I work for Pragma, and I've done so for 4.5 years now. I am a mechanical engineer by training, and I'm entrenched at a small coal mine here in Mpumalanga, where the sun is shining today. It's a lovely summer's day.
Thank you, Nardes. Then let's go next to another man in Mpumalanga, Lezile Kulu.
Morning, thank you, Johan. Good morning, everyone. My name is Lezile Kulu, industrial engineer by profession. Currently a reliability engineer working for Pragma, based in Mpumalanga, in one of the coal mines in that region.
Thank you, Lezile. The next up, Matt.
Thanks, Johan. Good morning, all. My name is Matt Bridger, and I'm a reliability engineer with a background in mechanical engineering. I'm currently assisting my client in the diamond industry across 3 provinces: Gauteng, Northern Cape and Free State, and sometimes I'm fortunate enough to travel to Tanzania. Unfortunately, I'm yet to convince them to let me keep a diamond, but I'm going to continue trying. Thank you.
Thanks, Matt. Okay, the next up is Richard.
Hey, thanks, Johan. Morning, everyone. So I'm Richard Groenhuis, also a reliability engineer at Pragma. I've been with Pragma just over 2 years now. Majority of my time I spent in the coal sector, but I've recently moved to the platinum sector and I'm based in the Rustenburg at the moment.
Thank you, Richard. Thank you. Yeah, Greg, you knew. I'm going to leave you for last, but you're not the least. So next up, Greg Palm.
Morning, everyone. My name is Greg Palm. I also have a mechanical background, and I've worked as a reliability engineer in the coal sector. I've now moved over to the iron ore sector in the Northern Cape, and I do some work with Reagat in the platinum sector as well. Good morning.
Thanks to the panel. So the webinar is open, and yeah, looking forward to the answers on your questions. So let's start off with question 1. Do you agree that this, what you see in front of you, is a typical day in the life of a reliability engineer? Or are you pulled into other projects that is not part of your role? You know, new expansions on the plant, etc., and things like that. And does the maturity of your client play a part in this? So let's start with, I don't know, Greg, let's go.
So the first one is, yes, generally it is, but I must also state, and I must also start with the third part of the question. Does the maturity of your client play a part in this? Absolutely, absolutely. In my experience, the maturity of my client plays a major role in how I am perceived and what my job title is understood as, number one. Number two, also the client's experience or exposure to reliability engineering plays a major role in what a day-to-day looks like, number one. The other one is, am I pulled into other projects? And yes, generally it is. I generally go to the person who shouts the loudest because, as I say, depending on where we are with which client, what their understanding is, whoever shouts the loudest at that particular point in time, you tend to go in. And you are, as a reliability engineer, you are seen as all things to all men. So whether it be mechanical, electrical, instrumentation, you perceived to be that magic one that can fix everything yesterday. Thank you.
But that can distract your focus, no? And then it all comes down again to, you know, proper communication of role and responsibility.
Exactly.
Okay, let's go next to Lizile.
Morning again. Yes, Johan, I do agree. The day pretty much looks exactly like that. It's just maybe in my sector we start a lot earlier. That review of breakdowns happens way before 7. With the GES, it's actually a shift change. So during that shift change, that handover section, that's where we discuss these breakdowns, what plagued the previous shift. Then we try and put in some controls, how to improve that going into the next shift. So yeah, it's pretty much like that. And just to emphasize what Greg mentioned about the maturity also, the maturity of the client has a very big influence of how the day progresses. So we might start off reviewing breakdowns. Depending on the maturity, we spend most of our time facilitating root cause analysis sessions, looking at LCCs and the likes of that. Yeah, I tend to agree with the structure of the day.
That's good. Thank you, Lizile. Let's move over to Matt Bridger.
Thanks, Johan. So I think I'd love to say that's what I do. Unfortunately, I don't. Ideally, we strive to get to that point. But in my current position, we're busy with a standardization project that entails both reliability and asset management activities. So a lot of my time is dedicated to creating asset types and their tasks while reviewing failure models. So I do assist with most things that deal with the client's asset management objectives. You know, to emphasize what everyone else has said, the maturity of the organization plays a massive part in what takes focus. And in my case, until the maintenance management system reaches a steady state, only then can we place focus solely on reliability engineering.
Yeah, Matt, that's very true. But yeah, you need to start somewhere, and really standardization and making things much easier based on tactics. Follow that through is the starting blocks to thereafter, because that's going to be the main. Everything is about data and the integrity of the data. And if that standardization and building blocks is wrong, then what are you going to do reliability on? So very valid point, and always part of any type of maintenance readiness project is the assets, the types, the maintenance plan and tactic developments, and then from there, all the different facets that's linked to it, from stock and spares and criticalities, etc. Okay, let's go over to Nardis.
I think the rest of the panel covered the major points. I think the one bit that I found is that even if your client has a reasonably high maturity in terms of physical asset management in general, it's entirely possible that the reliability engineering maturity may still lag.
Yeah.
This agenda here is a wonderful vision of what a reliability engineer should look at. It's almost impossible to actually build a day like this. I was saying to Lazile a little bit earlier as well, in the mining industry, you can only plan for about 30% of your day anyway. The rest of the day gets filled up whether you had something in planned or not. A great plan to have, very difficult to actually execute.
Perfect. Yeah, and then lastly, Richard, I think maybe from your experience specifically on that second part, are you pulled into other projects? So the whole thing around new designs, new, extension of plants, etc. There's always an operational readiness phase, of which maintenance readiness is a key component. Now, it's an existing plant, you do reliability on the operational data, and to now, you get pulled to assist with an operational readiness. So what happens to the plant during that time of reliability?
Yeah, so Johan, as was already said, this is the ideal as to what one would like to spend your time on. But we also know that in a production environment, things change on a daily basis, and they will always change. So I think it's important to balance your workload to be able to address the ad hoc work that does arise, but also keep your focus on the medium to long-term goals.
Yes.
The function of a reliability engineer is to plan and to execute the long-term and the medium-term strategy of an organization in terms of asset management. So it's important for both the RE and the client to realize that, but one must also be flexible in our day-to-day. As I say, in the production environment, things change on a daily basis.
Okay, perfect. Thanks, everyone. Let's move to question number 2. So I see in the question box, people already talked about tools and what you use on a day-to-day basis. So hopefully, this will give the attendees and the people in the group some answers on it. But yeah, what tools or methods do you use to perform your role, and are there alternative plans? So let's start with who wants to go first? Nardis.
Johan, this is again a great summary of tools and some of the very basic ones that we use all the way through to the more mature tools. Again, maturity comes up. I think the 5 whys is the very, very basic one that you need to instill at every single company. That's your artisan level troubleshooting type tool that you really need to at least be the champion for. Be the guy that goes through the breakdown job cards, and if there's not a 5 whys filled in, say, listen, we need some more information here. Maturing a little bit, you move on to your fishbones and your DMEACs and end up eventually with that reliability block diagram that you show on the bottom right there. It's wonderful to have all these tools. Again, the maturity level determines really which ones will be most useful. The one that I don't see listed here is simply going to the foreman and asking him a couple of questions. Normally the foreman knows what went wrong even before he filled in the job card. So if you maybe just prod him to go a couple of levels deeper, and give a bit more flesh to his answers on the job card.
Yeah, specifically, for foreman, maybe add a 3Y to a breakdown job card.
Yeah.
So you get some direction from that side. Let's go to Lizile. What do you use, and what's the challenges?
Morning again. I use, or I should say, we use the 5Y in combination with the fishbone. So the 5Y is for, as what Nardis has mentioned, is for more basic troubleshooting or basic problem solving. As you go into complex problems, you start to expand towards the nature or the effect of the problem, and you start looking at tools like your fishbone. But I think Pragma endorses the DMAC methodology, and it's a really good methodology to follow. As I think it's been said a number of times, as engineers, we quickly jump into the improve mode, but with a guideline or a methodology that you follow, like the DMAC, it really helps you structure the problem, define the problem, measure the problem, analyze it properly, and put controls. So it's a process that actually guides you in achieving or doing your root cause analysis.
Yes, definitely. Let's hear what you have to say, Matt.
Yeah, so as I mentioned earlier, my role's slightly different at the moment. So we're very busy with tactic development or review, and that's based on failure history, OEM manuals, and FMEAs.
Yes.
I've also been involved in, developing and reviewing of maintenance KPIs over inspections, MTTRs, and top 10 breakdowns. And when the one side of it that's been quite important from a reliability section is we performed a criticality analysis on the one section, because that's our starting point for creating our optimum maintenance mix for the critical A's or those assets where we've seen concerns or issues. Going forward, our plan is definitely that we want to implement a detailed RCA procedure, and that will include the 5 Ys, and if it's more complex, go on to detailed problem solving. We're also currently busy with an implementation project that will pull the spares from Sage 300 into OnKey, and once that's performed, that will give us a great starting point into putting together lifecycle costing and using financials in making good financial decisions.
No, good. Perfect. Good luck with that. Let's go over to Greg.
As my colleague said, we also use all three. We use the 5Y fishbone DMAC process. We're going over pretty soon to Kepner Trago training. That's a client requirement. However, I just wanted to add that the golden thread between all of these, which we've picked up, and Matt, you've touched on it just lightly, is once you look at a policy or a procedure with regards to defect elimination or breakdowns, you need to with the client develop a set of triggers, because as we said, how do we define or what is a simple problem? So without that little matrix and that set of triggers, you will not be able to differentiate which is noise and which isn't. Because currently, and ask all the REs, we literally have to play policeman and gatekeeper as well, because every sectional engineer has a problem, and he or she would like it investigated through one of the processes. However, without a set of triggers, we cannot categorize and prioritize which and where we look at those. So we forever in this in this cycle. We're falling around. So with a set of triggers that we're busy developing, we understand that if it's, for argument's sake, for one set of plant and equipment, if it's anything under an hour, a simple 5Y will suffice, and so on and so forth. We've even gone so far to develop that we've got a little 5W1H problem definition that we actually hand to the requesting engineer to say, listen, you want the problem solved, we don't have a problem, but empower us. Here's a bit of a form, fill it in, give us the detail, and that is making this so much easier. But initially, it's, as I said in the beginning, you attending to the guy or the girl who screams the loudest. So with the triggers, we're trying to bring standardization, semblance, and balance into the organization.
Thank you, Greg. Yeah, very, very insight stuff that. Richard, I'm going to put the question different to you, you know, specifically on the reliability block diagram and modeling. Do you believe that's a good and a compulsory tool to use during, let's say, green fields, red fields, or brown fields projects?
Yeah, Johan, I think a very, very powerful tool, the reliability block diagrams. It's a tool that unfortunately the asset maturity must be at a certain level for you to use it reliably. It's dangerous in the sense that if I tick all the boxes, if I fill in all the information that the software requires, it will give me an answer at the end of the day. But how useful is that answer? So very powerful tool. You'll of course need to do FMEAs previously to determine what your top failure modes are, your critical assets, as well as a good history of your delay analysis in terms of your MTBS and your MTTRs. But as you said, there's two ways to approach it. You can first of all do it at the start of a project before any ground has been broken. Draw up your entire project in your reliability block diagrams, run your simulation, see where your possible bottlenecks are, see where you can possibly have a high risk area in terms of failures, so that you can solve those problems before you start spending any large capital.
Exactly.
And from the other side, how I'm currently using it is with an existing plant. Pull up that plant in your reliability block diagrams. So at the end of the day, you have let's call it a digital twin of that plant. Now we can start playing around with scenarios. What happens if we add another asset to this production line? What happens if we have a critical failure on this one? Is there any way that we can maybe add buffers to the system in order to reduce the impact that downtime has on our overall production line, and so on? So I think it's a very powerful tool for you to play around and draw up scenarios in a digital format before you make any decisions which you will have to allocate resources or money to.
Oh, yes. And I think that answer actually goes into our next part when we talked about, you know, operational and the component of maintenance readiness within it. So question 3, what should a reliability engineer's input be when looking at operational readiness for projects? And I think let me start off on that side with Greg.
So let's start off. What should the RE's input be? The RE, when the organization, again, depending on maturity, but my experience and my opinion is, once the organization has sat down and conceptualized this and said, listen, this is what we want to do. One of the key figures in that conceptualization should be the reliability engineer. So I can go on for a month of Sundays on operational readiness, because this is actually the foundation of which most of us are going to be working as reliability engineers going forward. So as I said, if we start off at the right at the beginning, at the conceptualization, once we have our asset strategy, that is where the reliability engineer works from, but it is also where the reliability engineer has input in. Case in point, when we want to put up a new plant, or we want to open up a new mine, or I seen in the chat, we want to open up in a manufacturing environment, fast moving consumer goods, for argument's sake, we want to add an additional production line. This work needs to happen even before. At the concept, you need to be involved in literally every facet of going forward. And I'm just going to use 2 quick examples, and then I'll leave it over to my colleagues. I'll use, if you look at all on the screen there, everything in red is literally the RE's work. So I just want to talk on something called life cycle costing. So life cycle costing, that is the life of your asset. What are we going to replace? When are we going to replace it? How are we going to replace it? We take an action, literally put a monetary value to it, and then present it to the client. So what you literally want to do is you want to change your maintenance strategy, or you want to change your maintenance function from a cost center to, in fact, a profit center, by using things like net present value, where you go through all these steps with your client and with the team, and you develop models and scenarios, as Regardt has alluded to earlier. And you build this platform and you give them various options so that they can make the best decision based on the best available information at hand. Thank you.
Johan, you're muted.
Yeah, no, sorry. Thank you, Greg. I think from there, let's jump to Regardt.
Yeah, Johan, I think as Greg said, it's key for the reliability engineer to be involved from the day that project is conceptualized or brainstormed. There shouldn't be any uncertainty the moment that asset is on site, be it a new plant that was built, be it a new piece of equipment that was purchased. We should exactly know how are we going to maintain this, how is it going to fit into our larger maintenance strategy, our asset management strategy. The RE can also be involved in terms of selecting which assets we want to purchase. From a financial point of view, it might make the most sense to go with the asset that has the best output. But the RE can then have a look at how easily will we be able to maintain this, how reliable will this piece of equipment be able to operate in the current environment, and so on. So there's a lot of input that the RE can give from the pre-feasibility stage all the way through to the project closeout, and then of course after that through the entire assets life cycle, as Greg said, so that we eliminate all or as much uncertainty as possible, so that we know exactly how we will maintain it, how much will it cost us, what performance can we expect from this asset.
Exactly. Yeah. I think it comes back to maturity of a client as well. You know, if they don't have a defined framework for this, I think everyone on the panel has been to sites and clients where there's no framework like that, and you only get called when everything is commissioned. It's already in operation. And now you must go and run around and look for OEM manuals and maintenance manuals and call the QSs up because you didn't get a list to import to get the data ready in the system you're using. So maybe Matt is, you know, do you agree that, you know, it's based on maturity and it's there should be a framework for maintenance readiness, and it's a continuous thing. It shouldn't be seen as a project. Yeah, entirely. I think my current project, an example of that, we got pulled in from Pragma at a stage where everything was operating, and then the review started, where if the reliability engineer had been pulled in from the start, you know, a lot of some of the issues that we pick up now would have been addressed. I do feel, though, reliability engineering in itself is still quite a relatively new position. I think it was only officially termed in the 1990s. You know, so there's a big change management that goes into this as well. You know, especially if we look back at the model and we look at all the items there, a lot of those we deal with on our day-to-days after things have been implemented. You know, it goes with what everyone stated. If we can get involved at the start, a lot of issues could be solved. Good. Lizzie, from your perspective, I mean, you went through this whole exercise. So for the service Pragma provides to your client, and I mean, that was the good timing. We say they pulled us in, you know, just during building and delivery, pre-commissioning site. So how did that play out?
Good morning. I think that played out pretty well. We had the framework or the maintenance strategy in place, the reliability strategy in place. So when we started, we knew exactly what needs to happen, which spares do we need to have. It just made the maintenance part of it a little bit easier for us into going into the operation phase, into the operate and maintain phase. Yeah, it just goes to show that if you have the reliability inputs much earlier in your operational readiness project, it really streamlines the process further on, and it saves us the time to have to rework maintenance strategies or have massive inputs into the maintenance plans later on, because they were done right and the inputs were there initially.
Yes. Yes.
Thank you.
Nardis, thank you, Lezile. Anything you can add to it?
Yeah, we've had a similar experience here at my client, where we had a major project that changed the operating context of our coal mine quite a bit, going from a low seam area to a higher seam area. Pulling the reliability engineering into it right at the get-go, picking the correct assets for that new project, saved us a lot of money and heartache in the long run. It's absolutely the right thing to get your reliability engineer in as early as possible. I think putting it on this framework on the concept phase is exactly the right thing. It's not always possible. Again, maturity of different sites will influence that. But the reason that I like this is that the reliability engineer is not just a technical role. We have a business function as well. It's like Greg came back to the financials. If we can help a client make more profit, then we are paying for ourselves. That's really what the bottom line of what all of us are doing, and reliability engineering is no different. The other reason that I like being involved early in this process is this framework that we see on the screen now then also creates your KPI framework. If early on you say that my asset is going to cost me, for example, 10 Rand a ton in year 3, then in year 3, your management team already has a KPI to work with. You've got a budget already sorted out. Getting in early is absolutely the right thing.
Definitely. So now, as you mentioned now again, and I pull it back against a role, a responsibility well-defined, because reliability engineering is actually connected interdepartmental, and that should be established. There's going to be a lot of change happening, but from projects to procurement to finance to engineering to maintenance, it's a core function. It should be well-defined, well-standardized, well-communicated, the whole role and responsibility. Thanks, guys. I think let's move on to the next question. And now it's a little bit the more fun stuff. So where is everything going in the world? And, there's been so many pies in the skies and money wasted, and still so many silos when it comes to digital transformation. Everyone is running into different directions, and nothing is pulled together, and money is just wasted. Some pilots are successful, but then it get never rolled out. So I'm just throwing it out there for you. But let's look at this question just on, what are your day-to-day utilization, integrity, access, and challenges when it comes to really to data? And, is the information in time too late? If it's still manual, it takes long, but what's the integrity? All those different database challenges, and where do you see it's going with real time and maybe single repositories or platforms for a reliability engineer or engineers focusing on different areas and really applying their knowledge to in-time information? So I think, Nardis, I'm going to start with you on that side.
Thanks, Johan. I got into engineering because I like technology and I like being on the forefront of technology. And because apparently it's really difficult to make money by being a rock star. So this is the second best option. Digitalization is this buzzword lately, but in reality in engineering, specifically in reliability, we've been utilizing data in detail for a very, very long time. This isn't really all that new to reliability. The critical challenge has always just been translating that data into useful information, actionable information. You really want to, you don't want to tell someone, oh, this KPI is up 4.3%. You want to tell someone you need to go and fix this pump. That really means taking and understanding the data sources and living with that data along with the foreman and the engineers who live with the assets and feeding that into the maintenance system, because that's where your actions come from, your EAMS. So really the data that connects these four different parties is enabling the decision-making process. Digitalization, in my opinion, should be focusing on three things, really. Number one, getting the information on the right desk in time. Live data is great. It's fancy. It's really impressive to pull out your phone at the braai and tell people, oh, my continuous miner is cutting right now. But if your foreman is only seeing the data at the end of the day because he's busy with other work, is it really necessary? Or are you spending that money for nothing? Exactly. I prefer to really talk about just-in-time data. You need the data at the right time on the right desk. Secondly is interpreting that data into information that is actionable by the engineer or foreman. If you don't get into actionable items, then you're also not really getting all of the benefit that you need. And then finally, to get that action out and managed, you need to create a maintenance work order, because that's how you really track progress of the action. Exactly. And really, if you think about it, this is a predictive maintenance feedback loop. That's all this is digitalization is really enabling an already available system. We're improving systems by using digitalization. The automation isn't replacing anything. Exactly. So digitalization is a great tool, but it's important not to lose focus on the purpose of the implementation. So yes, good to implement it so that you enable the engineering and reliability teams, but be smart about how you plan your digitalization projects. Don't necessarily just spend money for the sake of spending money. Don't forget about your non-engineering data sources either. You're already generating data in your ERP systems and in your finance systems that you can pull into your system. Reliability is not just about condition monitoring data. If you can pick up an uptick in spending on a specific machine, that also tells you something. Yes. To get onto your database meetings aspect, at my site, we went through a big digitalization project. So all management meetings are data-based. The digitalization team deployed management dashboards. They pulled data and wrangled this data from all sorts of different sources and displayed on dashboards. And those dashboards are now the one version of the truth. So there's a very strong digitalization enablement on our site. However, it's a little bit high level at the moment. It's largely the management teams, and I think that's because the digitalization team said if we can impress the managers first, then we'll be safe to implement for the other departments later on. Hopefully that is now the next steps that we can get the reliability and the low-level digitalization work running smoothly.
Exactly. No, great stuff, great stuff. Yeah, I'm just watching time. So anyone else something to add to it? Lizile, I know you're at the plant that really wants to be the digital mine of the future. So maybe some input on that side. You know, I've mentioned in the beginning, money spent, maybe not the right focus. How should be the right approach? I mean, you know, do you first identify your biggest failures and your showstoppers and then try to gain, you know, put eyes on it? And then, but not eyes is not going to do anything. That should be built back into your enterprise architecture. Because if something happens, you need to have a countdown, but it needs to go through to the person who need to do the preventative action based on the prediction provided. So how's it going on your side? What can you add to this?
Yeah, it's been a journey. I mean, we've got a huge drive to go digital. And I think a lot of things should have been ironed out before we embarked on the digital journey. What are the requirements? What are we expecting to see so we can have proper alignment on the digital tools that we want to use? Because it gets a bit challenging trying to merge the data from all these digital sources and you try to paint a picture. And it goes back to data integrity. It's coming from a different source and you want to merge it with another data source, and it somehow needs to speak to each other. So if this was considered in the conceptual phase or the initial phase, it would save us a lot of time in trying to now go back and try to find a way of merging this data or sorting it or analyzing it. I think with all of these data or data banks, I would call it, we spend so much time trying to sort and analyze this and trying to turn this into information. And sometimes you need to be very quick. So the data velocity needs to be quite quick for us to react in time, depending on the nature of the problem that you're trying to address. Sometimes it's not really worthwhile to really act quickly on the data. So you need some sort of a guideline, something that shows me I'm heading in the right direction towards my KPIs. So I'm good. But something that to be, for me to be enabled to do any predictive, to have any predictive capabilities, I need to really have quick data, something that shows me I'm starting to go red, I'm starting to deteriorate, I'm starting to see a negative trend. So for me to act quickly on that. Yeah, I think that's my 2 cents on it.
Yeah, so maybe everyone's talking digitalization, but I think, data has been around everywhere. The problem is the silos. So I think biggest approach is based on a very structured approach on the showstoppers is the data is there, but how can we make it integrable? It should be integrated so that you don't go and look for it and try to make methods, out of the madness in it. Because if it's integrated, we talk about tables, you talk about reporting, and you don't need to go and look around for it. So I know this question we can talk 2 hours or 10 days about. So Richard and Greg, is it fine if we move on to the last question, question number 5? Thank you, everyone. So we can have some Q&As. Now, I've seen there were a question as well asking, is there any postgraduate studies for it, etc. And it actually comes in with this question. So what are the background and skills experience required for a reliability position? And then do you agree that what you see here should be a part of the basis foundation, but however, reoccurring improvements, we did touch on digitalization, which is master data and statistical analytical, approaches. But do you agree on this as a good learning pathway? Matt, let's start with you.
Yeah, I think before I get onto the pathway, I think it's important of where your background comes from. For myself, I was an environmental engineer firstly, which sounds odd as a reliability engineer now, but I was involved in the oil and gas industry, power generation, and even water sanitation. Then joining with Pragma, I've actually been on this pathway for a while now. It's fundamental as a reliability engineer to ensure, one, can you get some good data and do some basic problem solving. Sometimes it's required to go into more details. And I think, if we follow what's on screen as a minimum, I think it puts you in a good place. We can definitely meet clients' expectations by following this.
Yeah, perfect. Greg.
Okay, so let's start off at the beginning with your skills and experience. So it's where you start off, and it's the before RE position that literally molds and shapes you where you're going. For argument's sake, I started off the very, very, very old way. I started off as an operator, artisan, charge and foreman, general foreman engineer. So you'll hear that in my explanation. It is always from a practical point of view. So that is what people would call baggage, is actually that molds the way you think, where you come from. So again, experience cannot be taught in a classroom. So you would have to then first get your general qualification in engineering, go and work out and gain some formal experience, And as Matt says, this is the Pragma version, which is, by the way, linked to the ISO 55000. So it's not just a pie in the sky that we decided, the guys at Pragma decided, listen, we're going to do this. We linked it to an international organization and for physical asset management. And this is the pathway that thus far, as Matt says, has put us in a fairly decent stead, using your old experience with new tools that you are exposed to, and this repertoire just grows. It just grows. Like now, there'll be now something new, as I said, Kepner Trago. There'll be something as and when this evolution of reliability engineering takes place. Because this is why, personally, I love what I do. Because no 2 days, in fact, no 2 hours are the same. It's dynamic.
Yeah. No, brilliant. Richard, Lizile, something to add?
Okay, Lizile, you first.
Lizile. Okay. I think when I first joined Pragma as an AC engineer, I was taken through the learning pathways unconsciously. We didn't have a learning pathway for an RE, but the asset management landscape, it actually shows you where reliability fits in asset management. Measuring and managing the performance. I mean, how do you even begin to measure performance? What are the KPIs you're supposed to be looking at? How do you manage those KPIs? And how do you make tweaks within the operation in order to see this performance? We always talk about the balance of performance, cost, and risk. And we strive to achieve a perfect balance between these 3 elements. And I've been through most of the training, structured problem solving. It helps you out to understand how to even approach a problem, how to define what a problem is before you even start with the problem solving itself. Financial decision making, very, very important. I mean, the financial trade-off, once you've landed the project and you know what needs to happen, how do you make the trade-off? How do you convince the finance team that I need to spend money here to improve this asset's performance or to lower the risk of this asset? These are real eye-openers for me. Spare parts optimization, I could speak a mouthful on that. How to properly manage your inventory so that you don't have this spares that if you know that there are spares that are slow movers, you need to actually manage those so you don't tie up your money in slow moving spares. Just to find the balance between what do you keep and how fast does it move, how to optimize that. The training for me, it's quite important. It's actually a very great pathway that's been mapped out here.
Thanks, Lizile. I think, Nardis, Richard, is it fine if we move on to questions and answers, or do you maybe
to add one thing, because there was a question in the chat around postgrad study programs and how that could add value to reliability engineers' career. I think a postgrad, especially a master's, is very much it's shaped to what you require from it, or easily so. In engineering management masters, for example, you pick your topic, you pick your classes to sort of fit in to what you want to do. So I think it can add value. I don't think it's necessarily a requirement. I think what will also add value is getting certification. Once you don't necessarily need to do all of these different modules, but there's a CMRP certification that you can follow on that will help you sort of shape out your reliability engineering career. So I think just wanted to mention that to answer Lesiba's question in the chat.
Perfect. Thanks for that, Nardis. So
Johan, sorry, if I can just add one thing. I think I agree with Greg. So very excellent learning pathway. It's good to gain all this theoretical knowledge. But I think the benefit of working in the industry before you become an RE is with your reliability strategy, with your asset management, a large culture change is required to make these steps to grow your organization in terms of reliability, in terms of asset management, and working in the industry, in operations, working in production. One learns who your typical stakeholders are, your role players are, your cultural and your organizational challenges that one typically faces in a project like this, or implementing solutions like this. So I think having that background and that experience is something that's very valuable in order to make your life easier, to ensure that you involve the correct people to make these decisions, to implement these culture changes, these reliability and asset management changes, and at the end of the day, that's just what makes you a more successful RE.
Oh, yes, agree. Thanks, everyone. So just for all the attendees, we will be advertising another article on this learning pathway as soon as today, and as well as a follow-up webinar on the learning pathways of a reliability engineer. It will be presented by one of our experts, Benny Oosthuizen, as a reliability engineering subject matter expert. And that will be Tuesday, the 23rd, 10 o'clock. But yeah, just watch the platforms, LinkedIn, and the mailers that will be sent to you. Okay, and everyone, this conclude the questions. So we have 10 minutes left for an open room. If anyone would like to ask our panelists a question, yes, please raise your hand, and then we can continue. Okay, there is a hand. I just can't see who it is. Can you guys see? But go ahead and speak. I don't have the right one open in front of me. Let's see.
Hello, yes, thank you. Michael here.
Yes, we can hear you.
Thank you very much. I just want to find out, if I can ask about, within your experience so far in the industry, I don't know how far you've ventured into the rest of Africa, but what is the situation like? And is there really a pathway to really expanding for, say, your client's business, in terms of reliability engineering out there in Africa? Is there like a lack of knowledge out there? What's really the situation looking like out there in the industry?
I'll give the first step to the answer. So yes, we really have a lot of clients where we offer reliability, mentoring, and coaching programs. For up in Africa, it doesn't help to go and put someone down there and then, when the contract is over, no skills were transferred. So really the approach should be is what and where would you like to start, defining the roles, defining the resources, and then it's not permanently, but, put a time frame to it, let's say 6 months, and we upskill identified engineers to become reliability engineers via either, it can be a training program, but then it's practically on-site, a coaching and mentoring program to transfer that skills. So that is typically our approach to it. Anatidasha, did I answer your question?
Yes, thank you very much. Thank you.
Anyone else? Sipu? Sipu, unmute.
Oh, yes. I've now unmuted. Can you hear me?
Yes, we can.
Okay, sorry. Thanks for an informative session. I've enjoyed listening to the panel and their comments. Quick question, in terms of the, I think it's Lizzie that spoke about spending time, wrangling with data to be able to get information. So the question is, what sort of specific tools? I don't know if you would be able to share, but what sort of special tools beside Excel, MS Excel, that you guys actually use to dig in, connect to the various historians, and analyze the data that's there?
Can I try this one quickly?
Yeah, great.
Sipho, the most important tool for me, but other than Excel, is a cup of coffee. No, really. Going down to the workshop, it doesn't matter which workshop it is, going to sit and make a cup of have a cup of coffee and actually sit down and talk to that foreman or that artisan or that specialist and just picking his or her brain. You cannot believe the wealth of information sitting at workshop level. Taking that information and then, because that creates the context for you. So as I say, with everything you have data, you need to work and manage data into information and then transfer that information into knowledge. So sitting with where I would start, or where I normally start, is I actually sit and have a one-to-one conversation with the guys. And from there, I would then go and use, obviously, Excel spreadsheets and take it further. But it generally starts off and it goes like, how are you? This is who I am. What are the issues bugging you? And you'd be surprised how much you learn.
If I can add on to that, Greg's exactly right. The foreman and the artisans live with the data sources in the first place. That's where you get the framework for really what your data is going to tell you eventually. If you're looking at building a more formalized system, sort of your high maturity data science type systems, then you're really starting to talk about system architecture. So that's a whole another webinar that we should have at some point. But in broad strokes, you've got your historians generating data and collecting data. You want to take that data and then collect it into what we call a data lake, where you basically take all of your data sources that might prove useful and just collect them so that you don't bother the historian all the time, because the historian has an operational function as well. The data lake is then available to your data science or your digitalization team, your BI. From the data lake, you'll then build what we refer to as a data mart. So you start processing some of that data and putting it into ready-to-use little smaller databases. And from the data mart, you'll start getting your visualizations and your decision making. There's a myriad of different tools for each of these architectures. So the big ones you want to be looking at is a strong database system that can take your temporal databases, so something like InfluxDB maybe. Your starting point for wrangling your data is typically either Excel still or Python, playing around with your pandas libraries on Python, and in your visualization, you can use anything from the free tools like Grafana all the way to your paid, more expensive options like your Power BI and your ClickView. ClickView is the one we use at Pragma for our internal stuff as well, where you can even present the data to your management team or to your customer in broad strokes, where they can get the insights from the data presented to them themselves as well. So you give them processed data into information, but they can still slice and dice a little bit more to get the exact insights they need without using the BI team for every little step.
Yeah. Okay. All right. Thanks. Thanks a lot.
Sipho, I'll go and I'll just type my details in, and for anyone in the room, write it down if you have any questions. Just make contact to me, and I will then direct you to one of the panelists to support you on that side. I see we had a hand up, but it's off now. Okay, so there's time for a last question. Yeah, Sinetemba.
Hi, hi. How are you guys? I just want to find out. RE, is there a role for you guys in terms of playing in the service sector? What can you do in the service sector? Because I see you speaking more of mines and leaning towards manufacturing. Is there a role for REs in the service sector?
Goodness, I hope so.
Yes, most definitely. So REs, where there's an asset, there should be reliability. That's it. So, and that should be driven by everything we showed you. So just within Pragma, we have reliability engineers in the automotive industry, in the manufacturing industry. Even if when we talk services, you know, even if it's our condition monitoring area, but those guys I just call reliability engineers as well, because they do probability predictability studies. And that's mostly in water, in electricity, etc. So yes, most definitely, where there's an asset, it should be reliable, and that's the job of a reliability engineer.
If I can quickly add on to that, Johan, with our last, the reliability training that I attended in March, we had a bunch of guys from the Joburg municipality team, Joburg Water. They've got hundreds and thousands of pumps that all need to work. Otherwise, Johan, you can't take a shower tonight.
Yep.
That's the ultimate in reliability and customer facing. You know, if the municipalities are in on it, then absolutely reliability has a place with services.
Okay, thank you, everyone. It is 11:01. So, and we promised 1 hour. We would like to thank everyone, all the attendees, all the clients, all the Pragma people in the room. Thanks for your time and input and questions. And then for my panelists, thanks a lot, guys. I really, really appreciate it. Good answers, good discussion. So I would like to close the webinar and thank everyone. Yes, be safe and enjoy the rest of your day. Goodbye.
Thank you, everyone.
Thank you, everyone. Have a great day.
Thank you.
Bye. Bye.